Yes, and dear students, here we are going to revise our syllabus of Chemistry 5070 for examination 2023. Hope for the best. Here we start from first chapter, that is states of matter. Remember, this whole syllabus will be revised in 4 or 5 videos. Each video will be of 20 to 25 minutes. Hope this will help you for your exam. May you will get maximum grades and best grades. Best of luck. So here we are going to start. First chapter is states of matter, which has the following components: solid, liquid, and gas. Here in this chapter, we will discuss about the states and properties of solid, liquid, and gas. And when we talk about their properties, if we simply distinguish them, solids have fixed shape with regular arrangement of the particles. Liquid do not have fixed shape. They occupy the shape of the available container or the container in which they are present. And gases also not have fixed shape. They occupy the whole space of the container. Secondly, we will discuss about, if you are clear about this, you can mark this one. If you need little more practice, then you have to mark this one. And if you have not clear about this, then you have to mark this one in your checklist. This checklist will be shared with you if you need. Describe the structure of the solid, liquid, and gases in terms of particles, separation, arrangement, and motion. Okay. When we talk about the arrangement of the particles in solids, they are tightly packed. Remember, one common mistake which students commonly do, that they try to use the words molecule, ions. If you are not very much clear what type of these particles in the specific solids, there is no need to give the name, specific name, that is molecule, ions, atoms. So you have to use, as strongly advised, you have to use general words, which is particles. So here again, in solid, particles are tightly packed. They only vibrate about their fixed position. The kinetic energy of solid particle is less as compared to liquid. Due to regular arrangement of the particles, solids have fixed shape. Okay, when we talk about liquids, in liquid, particles are not tightly packed. They can move from one place to another place. They have loose spaces, not regular arrangements. Kinetic energy of liquid particle is more as compared to solid. And when we talk about gases, in gases, particles are far apart from each other. Their kinetic energy is highest. They can move from one place to another place. They occupy available space. Okay. Thirdly, when we discuss about, describe and explain the changes of state: melting, boiling, evaporating, freezing, and condensing in terms of kinetic particle theory. Okay, this is subjected when there is variation of temperature. Remember, when temperature change, then the kinetic energy of the particles of solid, liquid, and gas also changes. So firstly, we will discuss about solid. When we increase the temperature of solid, kinetic energy of solid particles increases. They move more violently, rather they vibrate more violently. At a certain temperature, the attractive forces among solid particles overcome and solid change into liquid. This is called melting. Remember, for pure solid, melting point is fixed. If there is impurity, melting point will decrease. For example, if a pure solid has melting point 50 degrees Celsius, impure sample of this solid may melt at 49, 48, 47, which is less than 50 degree Celsius. Okay. Secondly, we will discuss about boiling. When we increase the temperature of liquid, kinetic energy of liquid particles increases. They move more frequently from one place to another place. Their attractive force is also overcome due to high temperature, due to high kinetic energy, and liquid changes into gas. This is called boiling, and this is also a fixed temperature for a pure liquid. Remember, if there is impurity in the liquid, this will change, the boiling will change with more temperature. For example, if liquid boil at 100 degrees Celsius, due to impurity, this may boil at 101 degrees Celsius. 100 degrees Celsius, obviously this is the boiling point of water. If 100 degrees Celsius, this mean if it has impurity, this may melt at 101 degrees Celsius. For example, he can ask questions, suggest the boiling point of aqueous sodium chloride. So for aqueous sodium chloride, the boiling point will be 101, 102, 103, 105 to a certain limit. So this means due to impurity, boiling point increases. Okay, lastly, we will discuss about the effect of temperature on the gases. When we increase temperature of gases, kinetic energy of particles increases more. They move more randomly from one place to another place. Okay, here one thing is to remember. He can ask from you, what is the difference between boiling and evaporation? Evaporation take place at any temperature. Evaporation, remember, evaporation may take place, evaporation of water, for example, may take place at 25 degrees Celsius, 30 degrees Celsius, means escaping of some molecules from the surface. Whereas boiling, when whole liquid start to change into vapors at a fixed temperature, which is called boiling point. Okay, here we will discuss about freezing. What is the difference between melting and freezing? If we increase temperature, the temperature above melting point will melt the solid into liquid. And if we decrease the temperature of the liquid state, and at melting point, liquids start to change into solid. This is called freezing. Okay, hope you are clear with this explanation. Now, interrupt and explain the heating and cooling curve in terms of kinetic particle theory. For this, I would like to take the help. I would like to share this on page here. If I can share with you. Yes, heating and cooling curve. Here we will try to draw heating and cooling curve for solid and liquid. Here, temperature, states. For example, we have start for water -4 degrees Celsius. When it reaches at 0 degrees Celsius, it start to change from -4 to 0. Water is solid. At 0 degrees Celsius, this is melting point for water. It start to change into liquid. Remember, this is the stage. If this one is A, this one is B, C. Between B and C, both states are present. That is solid and liquid, solid, liquid, solid, liquid. When whole solid change into liquid, the temperature again start to rise at about, not about, exactly at 100 degrees Celsius. This liquid state change into vapor state again from D to E, both liquid and vapor state is present. This is boiling point. At E, the whole liquid changes into vapor state. Okay, here the question is, why temperature become constant at 0 degrees Celsius or at 100 degrees Celsius? Yes, the heating or the energy from heating is used to overcome the attractive forces between solid to change into liquid state. Same way, from D to E, the heat energy is used to overcome the attractive forces between liquid particles to convert them into gas state. Hope you are clear with this heating curve. Okay, now here we can draw the cooling curve, same for water. Here temperature, state, or even you can say here it is time course of the okay. If we cool the liquid state above 100 degrees Celsius, you can say 105 degrees Celsius. This is gaseous state. From gaseous state at 100 degrees Celsius, it changes into start to change into liquid. A, B, C. Again from B to C, both gas and liquid state is present. When whole gas changes into liquid state, temperature again start to decrease at 0 degrees Celsius. It again become constant when until whole liquid changes into solid. That is from to E, both states are present, which is liquid and solid. Below 0 degrees Celsius, again, it changes into solid, and temperature may drop to -4 or any temperature. Hope you are clear with this heating and cooling curve. Again, we are moving toward our content. If we see next content, interrupt and explain heating, it is clear. Hope you are clear with this. Okay, now next is describe and explain in terms of kinetic particle theory the effect of temperature and pressure on the volume of gas. Okay, remember this is directly proportional. Temperature is directly proportional to volume of gas. Until pressure is constant. There is no variation in the pressure. That is, we will not change the pressure on the gas. The container is same. Okay, if we increase the temperature, volume of the given moles or mass of the gas will increase. Particles theory, and if we decrease the temperature, volume of the gas will decrease. Again, describe and explain in terms of kinetic particle theory the effect of temperature and pressure on the volume of gas. Okay, if temperature is constant and increase in pressure, this is inversely proportional. Remember, this is inversely proportional. 1 over V, if we increase pressure, volume will decrease. You are very much clear about this. You also did this in physics as well. Okay, the next topic, which is also related to states of matter, it is divided into 1 and 2. Here we have discussed 1.1, all 5 topics. 1.2, describe and explain diffusion in terms of kinetic particle theory. Okay, what is diffusion? Highly suggested in chemistry that diffusion is the spontaneous and random movement of particles. Diffusion is the spontaneous and random movement of particles. Particles can move from one place to another place, not necessarily from higher to lower. They can move from one place to another place. So spontaneous or random movement of particles. This is passive movement, okay, without any use of energy. Describe and explain the effect of relative molecular mass on the rate of diffusion and gases. Okay, here, for example, this all I would like to explain with the help of notes. Um, yes, for example, we have two different gases um, in the tube. These two different gases are yes. For example, we have two different gases here. Uh, Gases are liquid. One, cotton wool is soaked in ammonia and NH3, and other cotton wool is soaked in HCl. Okay, after soaking, we will fit them in a glass tube, and the vapors from each liquid start to travel in this tube. If we calculate the mass of HCl, this is 36.5, and if we calculate mass of ammonia, nitrogen 14, each hydrogen 1, so 3, it become 17. So vapors will start to move from here. Ammonia is lighter gas, it will travel more. The vapors will um, uh, combine, are the fumes are white solid of NH4Cl, or white fumes of NH4Cl will be seen about this point. Why about this point? HCl has higher molecular mass, less rate of diffusion. Ammonia has uh, HCl has more molecular mass, less rate of diffusion. Ammonia has less molecular mass, so more rate of diffusion. So we can simply define rate of diffusion. Rate of diffusion directly proportional or inversely proportional to MR or AR of the gas. That is, if higher the molecular mass, rate of diffusion will be less. If smaller the or less the molecular mass, rate of diffusion will be faster. Hope you are clear with this example. This specific examples is asked in examination so many times. You will see the questions related to this. Okay, again, we will do move towards checklist. Okay, we are clear with the states of matter. If you have any questions, you can ask, you can text me, you can message me. I can explain it again. Okay, next chapter is atoms, element, and compound. This we will explain in next video. Hope you are clear with the previous one.